So let me show you what the Bohr model looks like. So when you look at the energy levels of the Bohr model energy levels, they're fairly straightforward. They're what we drew before. So they would look something like this. There's nothing fancy about them. And this is a very nice feature. But when you look at the quantum energy levels, they're quite different. And it really takes a long time to really understand that. You have to be an advanced undergraduate student or a graduate student to really try to grasp the details of this. Most of the time, it's really a graduate school question. So just to show you here, here's what you find in the quantum model. What you find here is that you have to include something called angular momentum into the model. And what you find here is that it's not 1, but it's 1s. And when you look at 2 in the Bohr model and the quantum model, here's what you find. I'm not going to make these as long because they're going to get... You find here is that there are not 1, but 2 energy levels, and they're staggered. And then when you go to the 3 energy levels, you get the staggered again, but now you find that you have 3. And if I continue, there's this really complicated issue about, like, let's say the 4th energy level. And when you get to the 4th, it's actually, believe it or not, it's below the 3D. And that guy is 4s. So it's really complicated. So where electrons live, they live in these energy levels. But in my opinion, this is well beyond the scope of this course. And so what we'll do here is that we'll use this model. Why the Bohr model? It's just easier, right? It's just an easier way to look at it, but it still has the same sense. But note, it's the Bohr model. That's not the quantum mechanical model. Okay, so here we go. So now that we're doing that, let's go look at the details here. So this is an important point. Right, so this is important. And this is what we know. This is what quantum mechanics tells us. The spacings of energy levels solely depends no, let's say it's solely determined, I think is a better word. They're solely determined by the electron structure of the atom. So in other words, if you talk about energy levels, then you talk about the atomic structure. However, if you talk about atomic structure, you talk about the energy levels. They're effectively one and the same. I can't tell you the difference between the two. So let me try to be as blunt as possible here, because I want to make sure that you understand what I'm saying here, is that this is what I mean. This implies that, how do I say this? Maybe I shouldn't say implies. This means since every atom has a unique atomic structure, then they have unique energy levels. And you're going to see is that because of this unique energy levels, what we say here is that these unique energy levels are really the fingerprints of an atom. Okay? It's the unique fingerprints of the atom. So let me give you an example. So as an example, it goes something like this. So let's say that I have a structure like this. So this is 4, 3, 2, 1. And then I have a different structure. Let's say that this structure looks like this, and then it goes like this, and then it goes like this, and then it goes like that. So when I look at this structure, you could see that these are two different energy levels, right? So if I look at this thing here, we can see here is that these are two different energy levels. So therefore, they're two different atoms. So now we get to the point is that how do we observe electrons in atoms? So now we ask the question, how are electrons observed in atoms? And the answer is quantum jumping. This is the best experimental evidence that we have. So what I have to do here is that to explain quantum jumping, we're going to have to do a series of jumps. Excuse me, a series of observations here. And I'm going to list them. I don't really know how I'm going to list them. Okay, how do I want to do this? Okay, here we go. One, how do I do this? Okay, here we go. When electrons jump, they emit electromagnetic radiation. In our case, we're not going to look at all of the different types of radiation. We're just going to focus on visible light. Even though they can emit other kinds of light. So when electrons jump, they emit electromagnetic radiation. Why? Because they're going from a higher energy to a lower energy, plus they need the energy of emitted light. So in this case, we could then say something like this. Let's say that we have energy levels that look like this here. So I have an energy level, and let's say that this guy is 3 and this is 2. So now what I have here is I have an electron that's jumping. That means as it jumps, it falls from energy 3. So in this case, the energy 3 is where? This is energy 3. So what happens now is that the electron falls to right here, right? It falls to here. So when I see this, this is the jump. So what did it do? It moved from a higher energy to a lower energy. So then I'm going to call that 2. So this is the lower energy. This is the higher energy. But in this process, it emits light. So then I'm going to say, this is the emitted light. So in this case, this is what we call emitted light. A lot of the times people will say, oh, this is light. So this is what they call a photon. So this emitted light is a photon. It's a particle of light. These guys must be equal. So when electrons jump, they go from a higher to a lower energy. Here's the other thing here. Any electron in the lowest energy state and this is what we call the ground state, will never, ever emit any light. In other words, it doesn't radiate. However, as we just saw, excited electrons only emit light while jumping to lower energies. And the reason why that is here is that because the energy levels is about electrical potential energy. And so to give you a sense of what I mean here is that I want to give you an analogy, is that when you're moving a box upwards, what happens when you're moving a box upwards? Well, what you find here is that you have the ground. And you're going to lift that box off the ground. So we look at the box here and we say, yep, that's at the low energy here, right? The bottom here is the low energy. But if a person picks this box up, we know that they've raised the energy of the box. So in other words, as we go upwards, there's an increase in gravitational potential energy. So by going upwards, there's an increase. The same thing happens in the atom. If I have energy levels here, let's say here and here, what we find here in these energy levels, what you find here is that in this direction here, let me move this a little bit over here, is that in this direction, this, you know what, I still need to move this over a little bit. So in this direction, this is the increase in electrical potential energy, or that means that this is the electrical potential energy. So as an electron moves up, there's an increase in energy. So you could imagine that this is the electron with the highest, with the lowest energy. That's the ground state energy. As the electron moves up, this one is higher energy. So we then say that because this is at a higher energy, this is the first excited state, which is the second highest, lowest energy. But if I was to move an electron all the way up to here, I would find then that I continue to increase electrical potential energy, and that's what we call the second excited state. So there's multiple ways of doing that. The same with the box. If I raise it a little bit, I could call that an excited state because it's a higher energy one. So here we go now. So now that we have this, they emit light. What do I mean by that? So when electrons jump from a higher to a low energy level, the electron de-excites and emits light. So now if I start to put this here, right? So jumping electrons move from higher to lower energy levels. And they emit light, as we talked about already here. And so here's what we find here. So if I now stick to the same energy levels that we were talking about, it goes something like this. So I have 3, 2, 1. And let's say that I have an electron right here. And what you're seeing here is that the electron can jump all the way down to here. So that means here is that as this guy jumps from here to here, what does it do? It emits light. So then light gets emitted. So in this case, we'll say that it's green light just because I drew it in green. On the other hand, I could have a red electron. There's no such thing as a red electron. All electrons are exactly the same. The only thing that differs about electrons is the energy. So when this thing falls down, what does it do? It emits red light. But here's the thing here. The size of the jump tells us the energy change. And so when I look at this thing, note that if I go from 3 to 1, this is a larger jump. So that implies that the emitted light is of higher energy. The fact that it's a big jump means that the emitted light has higher energy. And if I go from 2 to 1, well, this is a smaller jump. But if it's a smaller light, then the emitted light is of lower energy.